Hi everyone. So we'll be solving this problem number C of the big AtCoder beginner contest 278. So in this problem, Takahashi runs an SNS TwidI and it has got n users from user 1 to user n. And in each in TwidI, the users can follow or unfollow other users. So queue operations have been performed since TwidI was launched. And in ith operation, the ith operation can be represented by three integers ti, ai, bi, and the meaning of these three integers are as follow. Like if ti is 1, then the user ai will follow user bi, and if user ai is already following bi, then nothing will happen. And if ti is equal to 2, then ai will unfollow user bi, and if ai is already not following bi, then already nothing will happen. And if ti is equal to 3, then we have to answer whether ai and bi both are following each other or not. So if both of them are following each other, we have to print yes, and if this is not the case, then we have to print no. And when the service was launched, then no users were following each other, no users were following any user, right? So we have to print all the answers for ti equal to 3. This is the problem statement. So we can take a look to the constraints. So the n, that is the number of the users, can range up to 10 power 9. The number of operations, that is represented by q, can go up to 2 into 10 power 5. Ti is obviously 1 2 3, and ai and bi will range from 1 to n. And for any of the operation, ai is not equal to bi, and there exists I such that ti equal to 3. So at least one output needs to be printed, right? And now this is the input format. First two numbers will contain n and q, then the description of the operations. And output, obviously we have to print answers for all the ti equal to 3. So seeing this problem, like the easiest way to think of a solution will be to think something like that, like thinking of a 2D matrix kind of thing, which will tell whether I is following j or not, and whether j is following I or not. So using this kind of 2D matrix, we can easily solve this problem. But again, this 2D matrix will contain n cross n elements, right? And n is already 10.9, so this is again not feasible solution due to high space. And the like the solution that can be accepted can be implemented as follows. Like we can think of a map kind of thing, and this map will basically tell what are the users that are being followed by a particular user. So what are the users that one is following? So if one is following 3 4 and 7, this then this a one can point to a set that will contain 3 4 and 7, similarly for other users. So basically, the approach is to form a unordered map, and I'm using unordered map instead of map because the time complexity of unordered map is order 1 for each operation, as compared to map, where in that case it is log n. Okay, so I'll be using a unordered map, and the unordered map is like each key will be pointing to us unordered set, and this unordered sets will contain all the users that a particular user is following. So this way we can implement it. Now let's analyze the time complexity. So for each operation, we will be either adding a user or removing a user, right? So this is again an order 1 operation, and for ti equal to 3, again we will be checking whether a particular user is present or not, right? So this is again order 1 operation for each operation. So there will be like q operations. So the time complexity for this whole program will be order q. So since q is less than 2 into 10 power 5, it will pass. Now let us check whether the space complexity is acceptable or not. So each operation, we will be like adding a new key and adding one element or removing an element from it. So how many like total entries can be there? So we supposing for each every operation we are adding one user, right? So there can be how much? There can be at least at most q users, right? Added to this whole set, whole like unordered whole unordered map of made up of unordered sets. The whole complex data structure we are using that can have at most q elements. So again, since this q is less than 2 into 10 power 5, this is also acceptable. So after like analyzing the time and space complexity, we can see our solution will indeed pass all the test cases. So let's go back to its implementation. I have already like implemented it. I'll be show you the solution. Okay, so this is the solution. I am including unordered set, unordered map, and here this ll represent long int, right? So first I'm taking n and q as input. N is the number of users and q is the number of operations. Then I have used this kind of data structure. So this data structure is an ordered map of a long int and an unordered set of long int. Okay, so this will represent the user, and this will represent all the users that are being followed by this particular user. And now for each of the queue operation, I am taking t, a and b as input. And if t is equal to 1, that means a is following b. So I am accessing the corresponding set for a. So if there is no entry for a already in this whole data structure, it will the C++ will again assign a empty set for a. So whatever be the case, it will insert b. So if b is already there, it will do nothing because it is a set. And if b is not there, b will be inserted. Similarly for t equals to 2, in this case a unfollows b. So I'm erasing b from the ath set. And in case of t equals to 3, we need to tell whether both of them are following each other or not. So I'm just checking whether a is following b. So basically the syntax will be for this kind of checking will be to access the uh, unordered set for a and check whether b is there or not. So I'm checking whether any b is there or not. Similarly, I'm checking whether a is present in the corresponding set for b or not. So if both of the conditions are true, then I'm printing yes, and if any of them is false, I'm printing no. So this is the basic solution. We can test this approach for sample test cases also. So first sample input is this. Okay, now we can execute this program. So the output is no, yes, no, no. It's no, yes, no, no, right? Similarly for the sample input too. We can run it again. The output is yes and no. Yeah, it is yes and no. Similarly for the last sample output. We can run this again also. Okay, so the output is no and 2 yes here, 2 yes here. Yes, yeah. Okay, so it looks fine. So we can now submit the solution. Before submitting, I will comment this reading files statement because it doesn't work in AtCoder. Okay, upon submission, we have found that this program is accepted.